Have you ever given a thought about how Google Maps finds the shortest route to your destination? Have you ever wondered how Facebook finds links to your contacts and provides follow suggestions? What notion exactly runs behind these platforms? Watch the video till the end to get all these questions answered. Graph. A graph is nothing but a non-linear data structure arranged in a format of network made up of nodes, also called as vertices, and edges. A node is what holds information, and edge is the one that connects the two nodes with one another. Okay, let's take Facebook for an instance. There's a node, some user, and another node, another user. Now, these two users are connected with a connection, that is friendship. They are friends with each other. So, these two friends would be considered node here, and the connection between these two friends would be the edge. I hope nodes and edges are clear so far. Let's take the previous example and try looking at it from a different perspective. So this is a starting node connected to a category of nodes directly. So the starting node and the first category of people are friends with each other. Okay. Let's take a second category of people. So these people are connected with the first category of people and the starting node. So they would be called the mutual friends of the node of the friend and the people in the first category. Okay, let's take a third category of people. Now these people would be friends with the first category people, only with the first category. Alright, if we look through the graph, like while visualizing, the distance of the first node with the first category of people, the starting node and the first category of people would be way much less than the distance of the starting node from the third category of people. Why? Because this node is directly connected to the first category of people and indirectly connected to the third category of people. Alright, so graph traversal plays a very important role here. There are multiple ways to traverse through a graph, but in this video, we would be primarily focusing on breadth first search algorithm. What are we waiting for? Let's get tracking.
To begin with, let's construct a graph. So you can see here that I have already made a graph which consists of some nodes that have been numbered. Now you can see some red lines that connects these circles. So these circles are nodes and these nodes have been connected with edges. Okay. Also, you can see a rectangle around one of the nodes, that is 2. This symbolizes that 2 is the starting node. This is where we'll start traversing the graph. Okay. You can see an array and queue here. So this array maintains the record of all the elements, all the nodes that have been visited. You can see all the elements are marked 0 right now. That is because none of the elements have been visited till now. If we talk about an index 0, like the index 0, the value of index 0 symbolizes that the node with the value 0. The index value corresponds to the value of the node. So 0, at 0th position, the value is 0, which means 0 has not been visited. This is the queue. In this queue, we'll keep on pushing the elements, that is the nodes, the starting node, then the neighboring elements of the node. You'll see when I'll show you them in practice. Okay. This is the current node, a variable that stores the value of the current node that will be popped from the queue. And this is an array again that will store the final output of the program. So let's start from the starting node. We will push the starting node, that is 2, and we will mark it visited in the array. Symbolizing that 1 has been visited. Now there's a rule in BFS that every node of the graph has to be visited exactly once, not more, not less. That is why a visited array has been kept for keeping the records of all the nodes. Now, after pushing the element, we will pop this element and assign it as the current node. After assigning a value to the current node, we will look for all the neighboring elements of the current node. Since 2 is the current node, we'll look for its neighboring elements that are 1, 3, and 5. Okay, what do I mean by neighboring nodes? All those nodes that are directly attached, directly connected with the current node, that those elements would be the neighbors. So 1 is directly attached, then 3, and then there is 5. Now, before pushing these elements into the queue, we will check whether or not these elements have been visited. So let's check for 1. The value that at index 1, the value is 0. That means 1 has not been visited. Similarly, for 3 and 5, we see that the values are 0, which means they have not been visited. So now I will push the elements, the neighboring elements of the current node, 1, 3, and 5. As soon as I push these elements, I assign the value 1 to these elements in the array. So that I do not consider these elements again. Alright. Now, before popping the element and assigning the value to the current node, I'm storing the previous value of the current node in the array here. Now, I pop the element. Now, you must be knowing that in a queue, the first pushed element comes out first. So the first pushed element was 1. That means 1 would be popped first. It's like first come, first serve. So now we will look for the neighboring elements of 1. Yeah. So the neighboring elements of 1 are 2, 0, 4, and 3. But before pushing these elements into the queue, we check whether they have been visited or not. For 1, so 2. Since 2 has been marked as true, that means it has the Boolean value 1, which means that this element has been visited once and cannot be reconsidered for pushing in the array, in the queue. So 2 will not be pushed again. Then comes 0. 0 has not been visited, therefore it will be pushed. Then there is 4. 4 has also not been visited, therefore it will be pushed. And similarly, 3 has been pushed as it is marked visited here. Therefore, out of the 4 values for neighbors, only two of the neighbors would be pushed, and that are 0 and 4 because they have not been visited. Now I'm pushing the elements 0 and 4. Okay, now I'll assign store this value in the array and pop the first pushed element and assign it as the current node. Okay, I forgot to make them visited. Since I pushed 0 and 4 in the queue, they were supposed to be marked visited. I'm really sorry. Okay, yeah, you're good to go. Now, the current node is 3. So we will look for the neighboring elements of 3. What are the neighboring elements of 3? 1, 2, and 4. 1, 2, and 4. 3 has 3 neighboring elements. That means 3 elements are directly attached with 3. 1, 2, and 4. Now we'll look for whether these elements have been visited or not. 1 has been visited. 2 has been visited. 4 has been visited. Therefore, none of these elements would be pushed. Okay. Now we will, before assigning this as the current node, we'll store this value in the array here. And now we will assign 5 as current node. This procedure goes on until the queue is empty. Okay, so now we'll look for 5. 5 has 1, 2, only 2 neighboring elements. What are they? 2 and 0. We check whether they have been visited. 2 has been visited and 0 has also been visited. Therefore, these two elements will not be pushed in the array, in the queue. And we will again store this value here and assign 0 as the current node. Okay, now we'll look for the neighboring elements of 0. That are 1, 5, and 4. So there are 3 neighboring elements of 0. And we'll check whether they have been visited. 1, 4, and 5. You can see 1, 4, and 5. All 3 of them have been visited. Therefore, they will not be pushed into the queue. We'll store this value in the array and assign 4 as the current node. So 4 for 4. Okay. What are the neighboring elements of 4? 3, 1, and 0. There are 3 neighboring elements of 4. And let's check if they have been visited. 3 has been visited. 1 has been visited. And 0 has also been visited. Therefore, none of these elements will be pushed in the queue. And we will store this value here. Okay, you can see the queue is empty now. Since the queue is empty, the procedure of looking through the nodes stop here, and this means that we have traversed through all the nodes now. Thank you.